section 1.4, angle measure. Okay, we're going to start with some vocab here with the word ray. What is a ray? It has one endpoint and it extends indefinitely in one direction. So we can think about it as one side of it, like down here at point M, is like a segment. The other end will have an arrow like a line. So we would call this ray, we would draw a symbol like that, ray MP. We could also call it ray MO. You always have to start with the point that's the origin. Okay, so rays are named by stating the endpoint first, and then the other point on the ray. So ray MP or ray MO. Okay, opposite rays. Basically what we're doing here is we're taking ray JH and combining it with ray JK. Now, I always draw my arrows to the right when I'm creating my symbols. Okay, but ray JH goes to the left, JK goes to the right. When I combine them, they make a line, as you can see. Okay, some other vocabulary. We have an angle. This picture is an angle. Okay, it's formed by two rays that are not on the same line, and they have the same endpoint. So the common endpoint they share is point X, which is also called the vertex. Alright, so those are vocab words here. We're going to name the angle. This is important, and you're going to do this on your homework. But we're going to name this angle. In this picture, there are 3 ways to name the angle. 4 ways. We can name it angle. That's the symbol for angle. Angle Y, X, Z. Angle Z, X, Y. You'll notice that X is always in the middle. The vertex is always in the middle when you name an angle. We can also call it angle 3. Why can we name it angle 3? Well, we see that 3 right there. So we could name it that. We could also name it angle X. So there are 4 ways to name this angle. We're going to be practice naming these, and you're going to name some on your homework as well. Okay, there's also 3 parts of the angle. Okay, and I'm going to use the highlighter here, Q, M, and N. So right here we see Q, M, and N. They are on the line. Pretty simple. Okay, the interior are S and R. So if you want to think about the angle as a mouth that's about to chomp down that red line, it's going to eat S and R. And then lastly, we have the exterior, which is P and O. They are outside of the angle. If the angle closes, it will not eat those points, so to speak. So we know they are on the exterior. So we're going to be using those words throughout the year in geometry. Interior is like the inside of your house, like if you think about interior design. Exterior is outside. So think about the exterior of your house. All right, so we're going to look at this picture. It's kind of a confusing picture. All right, so I'm going to draw my highlighter on here, and we're going to name it. What is the vertex of angle 5? So I'm going to trace on angle 5. As you can see where I traced, I'm going to use a different highlighter here, different color. Okay, that's angle 5. What is the name of the vertex? Well, we look at the vertex of that angle, and the vertex is point C. By the way, you may want to pause the video now and see if you can answer these the right way. Okay, next one we have is, gotta highlight this angle. Name the sides of angle 5. So it has two sides. Okay, the two sides are always going to start with the vertex. So the vertex is C. It's going to be ray. I'm going to name the first one ray CJ, which is right here. And then I'm going to name ray CA right here. You could also name it CB. You could also name it CG. All right, write another name for ECL. Okay, so it always helps to trace this out on my paper. ECL. I'm going to name it a couple names. Angle 4, okay, because we see the 4 there in the interior. We could also name it angle ECK. We cannot name it angle C. Why can't we name it angle C? Because there are 1, 2, 3, 4 angles that have C in them, and we get confused about what they were. So the only other names we can write are angle 4 and angle ECK. Okay, last question. Name a point on the exterior of CLH. So I'm going to highlight CLH. Name a point on the exterior. Exterior is out here. Interior is in here where it's going to eat it. So it could be point D and E. Okay, moving on here. We're going to skip that slide. We're going to go here. Classify angles. We have 3 angles, and I think you guys have dealt with these before. First one is a right angle. A right angle is 90 degrees. We're going to be dealing with right angles all year in geometry. This little symbol down here, the little pink rectangle, you are going to see that all year long. That means 90. Many times in the pictures, there's not going to be the number 90. It's just going to have that box. Acute angle is less than 90. Okay, so we see our acute angle here that I've highlighted. Okay, you can see that it's smaller than 90. 90 is that pink dotted line. And then the obtuse angle, which is here, talking about obtuse now, it's greater than 90, but one thing to remember, it's also less than 180. Okay, so make sure you know how to classify those angles. We're going to practice that now. Okay, classify each angle as right, acute, or obtuse. This will also be part of the homework tonight. Let's look at AFB. AFB. So is that bigger than 90, smaller than 90, or the same as 90? We're going to look at that and say smaller. So that is acute. Okay, we're going to look at CFA. CFA. Now, here's where it might get a little tricky. If we're looking at CFA, and we see this box over here is 90, that little box, this other side of this whole angle here has to be 90. We're going to learn on the next lesson that 90 plus 90 is 180. A straight line is 180. So we know that one is a right angle. All right, AFD. We're going to make sure we're really highlighting the right angle, or the correct angle. AFD is point C there, CF on that line is a 90, so this means it's greater than 90, which means it is obtuse. Last but not least, we have CFD. We can tell the mouth is closed. We're for sure it's not 90 or greater than 90, so that is acute. All right, last concept today is called an angle bisector. So I'm going to draw an angle here. Draw with some nice straight lines. An angle bisector is a ray. So my angle bisector is in green. It is a ray that divides the angle in two congruent angles. That means the angles are the same. Okay, we talked about on a line segment, if I have two line segments that are the same, I mark the congruent by the slash. When I have an angle and I mark them the same, I mark them with an angle symbol. So every picture you do with an angle bisector should look just like this. For example, I'm going to make some points on here so we can name these angles. We would say that angle ABD is congruent to angle CBD. Those two angles are the same, and I have marked them with my congruent markers. So what ray BD has done is has cut that angle in half. Okay, we'll do some examples here. All right. So I'm going to draw all these the same. I don't really know what their measurements are. I'm going to draw them all as acute angles unless it says otherwise. Okay, so it says KN. So I'm going to draw in a different color so we can see it. KN. Here's our vertex. So this is K, and this is N. They bisect JKL. So this will be JKL. And then I'm going to draw my congruent marks in here so I know those two angles are the same. What I'm going to do is I'm going to label my picture. Okay? So JKL equals 9y plus 5. So if it's the whole angle, I'm going to do this, and I'm going to put 9y plus 5. JKN is 5y plus 2, so I write that in here. And that's all I have. So what I'm realizing here is I don't have anything here for NKL. But what I know is that these are both the same. They are both congruent. So what I'm going to do is I'm going to label this angle as 5y plus 2. And I know that the two smaller angles are going to add up to the larger angle. So I'm going to set up my algebra. And as usual, hopefully I have room. I'm going to kind of do it over here on the left side. So I have 5, I'm going to change colors. I have 5y plus 2 plus 5y plus 2 equals 9y plus 15. For all you algebra gurus out there, I'm going to combine my 5y's, and I'm going to combine my 2's. 5y plus 5y is 10y. 2 plus 2 is 4. Equals 9y plus 15. Okay, I'm going to subtract 4. So I get 10y equals 9y minus 15. Sorry, that was terrible. 15 minus 4. 15 minus 4 is 11. So I'm going to subtract now 9y from both sides. And I get y equals 11. I'm going to ask you in class when we do this, are we done? Does it say to find y? It says find the measure of JKL. So what I do, as always, is I take this 11 and I plug it back in. So now I have 9 times 11 plus 15, which is 99 plus 15, which equals 114 degrees. Now, I didn't draw this as an obtuse angle. It should be obtuse. I didn't know that beforehand. You can just draw all your angles the same. Your answer is y equals 11, and the angle is 114. All right, let's try another one. I'm going to draw my angle. This time I'm going to draw it smaller. So we have KN bisecting again. I'm going to pick a different color. Once again, you guys are just sketching these like me. Here's K. Here's N. And it bisects LKM. So we have LKM. So LKM is the big angle. KN is the bisector, cutting it in half. So those two are congruent. LKM, the big angle, is 7x minus 5. NKM is 3x plus 9. We're trying to find LKM. Pretty much the same problem we did before. Once again, if LKN, if this is blank, what I'm going to do is I'm going to put in 3x plus 9. And once again, I am going to do 3x plus 9 plus 3x plus 9 equals the whole thing, 7x minus 5. Combine the x's, combine the 9's. I'm going to get 6x plus 18 equals 7x minus 5. I'm going to add 5 to both sides. So I'm going to get 6x plus 23 equals 7x. And now I'm going to subtract 6x. And so 23 will equal x. Does it say to find x? Well, we have to find x first, but it really says find LKM. I'm going to take my 23, plug it in. This is where you're going to need a calculator. 7 times 23 minus 5. I don't know 7 times 23. I'm going to type in my calculator. I'm going to get 161 minus 5 equals 156. All right. So we solved it. The key is drawing your picture and labeling your picture. And actually, a lot of times, I'm going to draw the picture for you, and I might even label the picture for you. And then you guys will have to solve. All right, we're on our last slide here. It's our same picture. So I'm going to draw that again. It's good to draw acute angles because you can draw smaller. Okay, we have K, N, different color. That's bisecting it. It's cutting this angle in half. And we have JKM once again. Now, it says if NKJ oh, by the way, these are congruent. Mark them congruent. NKJ is 7x minus 9. And JKM is x plus 3. Find JKN. Now, I don't have this big number like before, but guess what? I don't need it. Okay? Because those two angles are equal, all that means is now I set them equal in an equation. 7x minus 9 equals x plus 3. I'm going to add my 9 first. So I get 7x equals x plus 12. 3 plus 9 is 12. Subtract x from both sides. If you want to put a 1 in front of there, you can. So we get 6x equals 12. Divide both sides by 6. X equals 2. Once again, circle what you're finding. We're not finding 2, we're finding JKN. So I'm going to take my 2 and plug it in for x. 7 times 2 minus 9. I know 7 times 2 is 14. Minus 9. And that angle is only 5 degrees.